Welcome back to Further Solutions Academy. Further Solutions Academy. On this video, I'll be walking you on Gaussian elimination method. Gaussian elimination method. It's a very simple part of mathematics, which you have to get it. By now, you understand what is called rule reduction. Echelon form. This time around, you just want to reduce, but you know that echelon form, we are talking about a leading item, which is a leading element must be what? 1. Like when you are having 1 is B, is 0, 1, G, is 0, is 0, M. Now, this is what? Okay, this is going to be 1. Sorry. This is going to be 1. Which is going to be what? 1. I can have this as C, N, P. Now, can you see this is a what? Echelon. Because the leading rows are what? 1. The leading elements are what? Are 1. And we have done what is called column reduction and row reduction. This is a row reduction as an example. Now, okay. For instance, I have this particular problem and I'm has to solve for x1 and x2 and x3. I want to use Gaussian method. Now, the solution to this problem, the first thing I will do, solution to this problem, the first thing I will do is that, this very, very important, which is I want to make it in a matrix form, which I have this, and 3, 2, 1. I will be having something like this, x1, x2, x3, which it will be equals to 3, 11, and minus 5. Okay, that is what I will first do. Now, I will now make it augmented, like the augment matrix, the augmented matrix will, which is going to be what? 1, 2, minus 3, 2, minus 3, 2, 1, and what? 3, 11, and minus 5. Down. Can you see? Now, at this point, I can now start to reduce. Let's start to reduce this particular matrix. Now, I can now say that my row 2 can be equals to row 2 minus 2 row 1. I can also say that my row 3 can be equals to row 3 minus 3 row 1. Now, to have something very good, which by so doing that, I'll be having after that, I'll be having 1, 2, minus 3, and 3. And also, I'll be having 0, is 0, okay. I'll be having 0, I'll be having minus 5, I'll be having 5, and 5. Now, is 0, minus 4, 10, and minus 14. Now, that is what I'm going to have there, which, yes, 9 minus, it will be 14. Minus, yes, that'll be, is it 14 or 9? Hope I'm not making mistake. No mistake. Now, I can say that my row 2 can be equals to 1 all over 5 row 1. Row 2 rather. I can also say that but my row 3 can be equals to 1 all over 2 row 3. Just to have a simpler number that will be easy for me to handle. Minus 3, 3, and don't forget this is my augment. I have 0, I have minus 1, I have 1, and I have 1. And is 0, minus 2, 5, and minus 7. That is what I'm going to have. That's what I'm going to have. Now, the next thing I will do now, I want to turn this to a 0. I want to turn that to what? To a 0. Now, what can I do to reduce that to a 0? I can say that what? R3 can be equals to R3 minus 2R1. R3 minus 2R1, which I will be having 1, 2, minus 3, and 3, 0, minus 1, 1, 1. Here will be 2, 2. That is 0, is 0. This one will be 2 and 5. That will be 3. That will be 3. And here will be 2 minus 9. Minus 9. Now, that is very correct. Now, since I have that, if I want to do it very well, it's not necessary. I can say that my R3 become 1 all over 3 R1. I mean R3 rather, which there won't be any problem. I can now say 1, 2, minus 3, 3, and also 0 minus. If I also do it that my R2 can be equals to minus R2, there won't be any problem, which I will have 1 and minus 1, minus 1. And here will be 0, is 0, 1, and minus 3. That is mine. I will have my argument. Now, can you see that this become a what? Echelon. Can you see it become a what? Echelon form. Can you see it's in form of an echelon? You can see that leading rows are 1. They are 1, 1. Okay, when we are talking about eigenvalue and eigenvector, we'll be talking about free elements and pivot. All these things, we understand that when we get there. Now, how do I apply my this thing now? It means I'm saying that what? My x3 equals to minus 3. My x2 minus x1, x3 equals to minus 1, which I will be having my x2 will be equals to minus 1 plus what? Which is going to be what? It will be, this one will be minus, which is going to be what? It will be 4. It will be minus 4. Which is going to be minus 4. It will be minus 4, indirectly, minus 4. And my x1 plus 2x2 minus s3 equals to 3. Now, this is going to be what? x1 plus 2 bracket of, what is my s2? That will be what? I'll be having minus 8. And what is my s3? S3 is minus 3. That will be what? 9 plus 9 equals to 3. Now, this one become 1. 1 minus, it means x1 equals to what? 2. x1 equals to 2. It means what I'm saying now is my x1 equals to minus 3, s2 equals to minus 4, s3 equals to, s3, I made mistake, sorry. My s1 equals to 2, s minus 4, and minus 3. That is. Now, how do I know that what I've done is correct or not? It's just simple. Pick any of the convenient equation, which I can pick s1 plus 2x2 minus 3x3. Can it be equals to 3? Let's check. Now, what is my x1? I have 2 plus 2 bracket of what? Minus 4 minus 3 bracket of what? Minus. Can it be equals to 3? I don't know. Now, this one will be 2 plus minus 8 plus 9 equals to what? Can it be equal to 3? This one becomes 3 equals to 3. Can you see? It means what I've solved is very, very correct. What I've solved is very, very correct. If that does not obey, it means I've done wrong thing. I've done wrong thing. This is my board, this is my duster, is not very good. Now, let me try to solve another problem using Gaussian elimination method. Okay. Okay, now look at this problem. Look at this problem. I think let me solve another problem using Gaussian elimination method. Now look at this problem. Okay, look at this particular question. Solve for x1, s2, and s3 in the equation s1 minus 4s2 minus 2s3 equals to 21. 2s1 plus s2 plus s3 equals to 3. 3s1 plus s2 plus 2s2 minus x1 equals to minus 2. Now, solution to this problem is very simple. Now, the first thing I will do, don't forget, coefficients, I will pack them up, which I will be having 2, 1, 2, 3, 2, minus 1, which I will be having my x, it will be x1, x2, s3. It will be equals to what I have here, 2, 1, 3, and minus 2. That is the first thing I will do. Now, since I've done that, I will now say that I will turn it to augment. I will augment it. I want to augment this matrix. It means 1, minus 4, minus 2, 1, 2, 3, 2, minus 1. And that will be 21, 3, and minus. That is going to be. Now, since I have that, I think at this point I can now start to reduce. I can start to reduce, which I will have, it means I will say that R2 can be equals to R2 minus 2R1. R3 can be equals to R3 minus 3R3. Now, since I have that, I'm ready to manage the board. I think at this point I can answer that 1, minus 4, minus 2, and 21. This will be, I have, which I'll be having 0. I'll be having, that'll be 8. 8 minus that, it will be 9, which will be, I have 6. And I have minus 39, and this will be 0, and here will be 14, here will be 5, and minus 65. Now, I will move on to the next one. What can I do? This is the problem I'm having now. I want to turn that number to what? To 0. Before, I can say that my R3 can be equals to 1 all over 14 R1. I mean R3, for it to be convenient for me. Do you know that I can also turn that that my R2 can be equals to 1 all over 3 R2, which I will have 1 minus 4 minus 2, 21. Don't forget, this is going to be, I have 0, I have 3, 2, and divided by that with 13, if I should get yes, 13. I have minus 13. And here will be 0, 1, and it will be 14, 5 all over 14, and also minus 65 all over 14. Okay. Now, this can now be very, very easy for me to reduce. It means my R3 can be equals to R3, 3 R3 minus R2, minus R2, minus R2. Now, it means I'll be having 1 minus 4 minus 2, 21. Don't forget this argument, but it does not be necessary. I have 0, 3, 2, and minus 3. 13 rather. Now, this is to be 0, 0. That is what I want to achieve. And I'll be having minus 13 all over 14. And here will be that will also be equals to minus 13 all over 14, which is that I will be having minus 13 all over 14. Now, that is what I will be having. Now, if I like, I can say that R3 can be equals to minus 4 all over 13 R3, which I will be having 1. And is that all? Yes. Yes, so just to reduce that to 1, it means I'll be having 1, minus 4, this, minus 21. Don't forget this. I'll be having 0, 3, 2, minus. Now, this one will not be 0, 0. This one will be 1, 1. This is minus, minus. Is okay, 1, 1, because I've told you minus is there. Now, by so doing that, I've successfully make use of my what? Gaussian elimination method. I think I can now say that what? My x3 equals to what? 1. My x3 equals to 1. And my 3x2 plus 2x3 equals to what? Minus 13. Which I will be having, this is going to be 1. 3x equals to what? 13 minus 13 minus, which is going to be minus 15, which is my x2 will be equals to minus 5. Now, I'll also move on to the next one. X1 minus 4x2 plus, minus 2x3 equals to 21. Now, I think there won't be any problem by having x1 minus, which is going to be plus, which will be 20 minus, this is going to be 4, 4, 4, 4, 3. I will have plus 2 equals to 0, which is 18. X1 equals to 21 minus 18, which I will be having x1 equals to 3. Now, we have x1 equals to 3, x2 equals to minus 5, x3 equals to what? 1. Now, how do I know that what I've done is correct or not? Pick any of the convenient equation, which I have 3x1 plus 2x2 minus x3. Can it be equals to minus 2? Let's see. Now, if it is not equals to minus 2, it means what I've done, something is wrong somewhere. I have 9 plus, it will be minus 10, and this also will be 1, minus 1. This minus this, it will be what? This minus, it will be minus 1, which is minus 2 equals to minus 2. It is very correct. Now, it means I don't need to stress or recheck what I've done. Can you see why Gaussian elimination method is very simple? Before I end this part of Gaussian, I will try to solve four unknown variable equation on the next video. Don't forget, you are home with a further session. Once again, I really appreciate your thanks for watching.